Why does the universe allow us to exist? The universe did not have to be this way. The fundamental constants of physics, the strength of gravity, the mass of the electron, the force binding atomic nuclei, these could have been different. In most versions of physics, nothing interesting happens. Stars do not form. Chemistry does not work. Life is impossible. Yet against astronomical odds, our universe has precisely the parameters needed for complexity to emerge. Change the gravitational constant by a hair, and galaxies never coalesce. Adjust the strong nuclear force slightly, and atoms heavier than hydrogen cannot exist. The universe appears fine-tuned for life with a precision that defies comprehension. Is this cosmic coincidence, evidence of design, or a clue to something deeper about the nature of reality? Welcome back to the Conscious Observer. Today we confront the fine-tuning problem and ask why the universe allows us to exist at all. Let us consider some specific examples of fine-tuning. The cosmological constant, which controls the expansion rate of the universe, is fine-tuned to about 1 part in 10 to the 120th power. If it were slightly larger, the universe would have expanded too fast for matter to clump into galaxies. If slightly smaller, everything would have collapsed back into a singularity. The ratio of the electromagnetic force to gravity is about 10 to the 36th power. Change this significantly, and stable atoms become impossible. The strong nuclear force is within 1% of the value needed to produce carbon in stellar fusion, the carbon that forms the basis of all life we know. The mass difference between protons and neutrons is precisely what allows hydrogen to be stable while enabling heavier elements to form. Each of these parameters must be exquisitely calibrated. The probability of all of them being right by chance seems vanishingly small. Physicist Brandon Carter introduced the anthropic principle in 1973 to address this puzzle. The weak version states something almost trivially true. We can only observe a universe compatible with our existence. If the constants were wrong for life, no one would be here to notice. This is selection bias on a cosmic scale. We should not be surprised that our universe supports life because we could not exist in one that does not. But this feels like a non-explanation to many. It is true but unsatisfying, like explaining why you won the lottery by noting that only winners can ask why they won. The strong anthropic principle goes further, suggesting the universe must have properties allowing consciousness to develop at some point. This version is more controversial, implying that observers are somehow necessary, that a universe without the possibility of awareness could not exist. One scientific response to fine-tuning is the multiverse hypothesis. Perhaps our universe is one of unimaginably many, each with different physical constants. Most universes are sterile, their constants incompatible with complexity. But in a multiverse vast enough, some universes will hit the jackpot by chance. We necessarily find ourselves in one of the rare winners. This transforms the fine-tuning problem from a mystery into a selection effect. We are not special. We are just in a special place. The multiverse idea gains support from inflation theory, which suggests our universe bubbled off from an eternally inflating space that spawns countless other bubbles. String theory, too, predicts a vast landscape of possible universes with different physics. But the multiverse hypothesis is scientifically controversial. We cannot observe other universes. The theory might be untestable in principle. Critics argue it is metaphysics dressed as science. For many throughout history, fine-tuning suggests a designer. The universe looks engineered for life because it was engineered for life. A cosmic intelligence set the parameters, knowing they would yield complexity, consciousness, and perhaps even beings who would one day wonder about their creator. This is the oldest explanation for apparent cosmic purpose and remains compelling to billions of people. But it raises as many questions as it answers. Who designed the designer? What are the designer's motivations? Why this particular universe rather than another? Science traditionally avoids design explanations because they tend to be conversation stoppers rather than productive hypotheses. Yet intellectual honesty requires acknowledging that design remains a logically possible explanation, one that many find more plausible than coincidence or multiverse. Physicist Lee Smolin proposed an imaginative alternative called cosmological natural selection. He suggested that black holes give birth to new universes, and the physical constants vary slightly in each offspring universe. Universes that produce many black holes will have many descendants. Over cosmic generations, the multiverse will come to be dominated by universes optimized for black hole production. Intriguingly, the conditions favorable for black holes, such as long-lived stars and heavy elements, overlap significantly with conditions favorable for life. We exist not because the universe was designed for us, but because we are a byproduct of cosmic reproduction. This theory is speculative and difficult to test, but it shows that naturalistic explanations beyond pure chance are conceivable. Fine-tuning might have an evolutionary explanation we have not yet fully grasped. Here we return to a theme woven throughout this channel. What if consciousness plays a deeper role than mere observer? Some interpretations of quantum mechanics suggest that observation is necessary to collapse quantum possibilities into definite realities. If consciousness must be present for the wave function to collapse, then only universes capable of producing consciousness can become fully real. The fine-tuning problem dissolves because universes without the possibility of observers never concretize. They remain in a state of quantum limbo, mere potentialities in an abstract space. This connects to John Wheeler's participatory universe concept. Observers are not accidents but necessities. The universe fine-tunes itself for life because life is what makes it actual. This idea is philosophically radical but not obviously wrong. It takes the measurement problem of quantum mechanics and scales it to cosmological dimensions. Philosophers have long puzzled over why there is something rather than nothing. Perhaps the fine-tuning problem is part of this deeper mystery. Physicist John Wheeler imagined a self-excited circuit, a loop in which the universe brings forth observers, and observers bring forth the universe. Neither is prior, both are necessary. The cosmos is self-explaining, self-creating, self-aware. This resembles ancient ideas like the Ouroboros, the serpent eating its own tail, a symbol of self-reference and eternal return. Modern physics increasingly suggests that information and observation are not peripheral but central to reality. Perhaps the universe had to be fine-tuned for consciousness because consciousness is what creates the universe. We are not accidental byproducts of blind forces but essential participants in cosmic existence. The observer and the observed arise together. Regardless of which explanation is correct, the fine-tuning problem invites wonder. We live in a universe of staggering improbability, a cosmos balanced on a knife's edge between sterility and fecundity. Every star, every planet, every living cell exists because the fundamental constants fell within an almost impossibly narrow range. You are here, conscious and curious, because the universe permits exactly this and almost nothing else. This is either the greatest accident in existence or the deepest clue to the nature of reality. Either way, it is worth pausing to appreciate. You are the universe looking at itself with astonishment. You are matter that has arranged itself to ask why matter exists. Whatever explains this miracle, whether chance, necessity, design, or participation, you are part of it. Your existence is evidence. The fine-tuning problem has no definitive answer. Each proposed solution, multiverse, design, cosmological selection, anthropic participation, opens new questions. This is not a failure of science or philosophy. It is a sign that we have touched something genuinely deep. The question of why the universe allows consciousness to exist may be unanswerable, or its answer may revolutionize our understanding of reality. Perhaps the question itself is the point. Asking why creates meaning. Wondering generates wonder. The universe has produced beings who ask why they exist, and in asking, we participate in something larger than ourselves. Throughout this series, we have seen how quantum mechanics, time, consciousness, and cosmology interweave into a tapestry of mystery. The conscious observer began with an experiment involving two slits and has led to the edges of existence itself. We will continue this journey following wherever the questions lead. Until next time, remember, in a finely tuned universe, you are the finest tuning of all. Keep observant.